So my name's Keith. I'm Chief Architect at Slack. It's a pleasure to be here at QCon. I probably had a less grueling commute to get to QCon than most of you. Our office is about 4 blocks away. Sid stole my poll the audience for who uses Slack line. So now that I know that a lot of you know what Slack is, this feels a little forced. But when you talk about Slack, a lot of times the news stories that people write these days are about new features like voice calls, or sometimes they're about the sort of some of the strategic things that might be more interesting to developers, like platform. A lot of people really enjoy writing about bots for whatever reasons. A lot of stuff gets written about bots. But for the purposes of this talk, I'm going to be focused on the sort of a core original use case of Slack, which is persistent group messaging. Right? So the product category there that we're trying to define is group messaging. Right? So a little bit like IRC, right? Self-curated channels of people with the same interest groups talking in a real-time way, right? Talking in a conversational sort of setting around a kind of virtual water cooler instead of like in a comment thread or an email thread where it sort of feels long form. But also persistent. Right? So if you leave work at 5 and get back at 9, you can catch up on whatever happened in the ops channel while you were away. And this is sort of a really simple vision to kind of state. It turns out that executing it well and executing it at scale in a way that you can operate is pretty challenging. So what you can expect here today is that we're going to go through a little case study of how a typical Slack session works. So we'll have a user and their client connecting to sort of Slack's infrastructure running in the cloud, receiving messages, sending messages, and all the sort of internal pieces of Slack that interacts with. Also talk about some of the challenges we face right now. Right? So Slack's a very new product. It's only been in operation for a little over 2 years at this time. It's been operational and up for all of its users that whole time. So it's still busy being born. And I'll talk a little bit about our plans to address them and what state they're in. And I've done a couple of talks at QCon before, with different hats on, and I've done a lot of these tech talks. And there's this tendency to get frozen into talking about your thing as if it's perfect. In part because it's kind of, you're insecure, right? You're talking about the work you do all day long. You want to make it sound like you work at a cool company, full of smart people, doing hard stuff, which is true more often than not. But it's also a little bit of a fib, right? There are lots of things that aren't perfect. There's lots of things that if you had sort of perfect hindsight, you'd go back and do differently. And I'm going to try and not paper over them too egregiously. So a few numbers to get us some sense of scale here. In terms of raw headcount of users, Slack is sort of megascale and not gigascale. And so there are millions, not billions, of connected users, right? Millions with an M. We have peak connected users of 2.5 million. And I'm sure somebody will correct me if this turns out to be wrong. I think that's the largest sort of instantaneous number of open WebSocket connections of anything out there. I might be wrong about that. I look forward to finding out if I am. What's more unusual about the scale and sort of load of the way that people use Slack currently isn't so much the raw crush of bodies, although that's getting more and more challenging. It's actually just how intensively they use it. Right? So we're not something that people kind of log into and write a few messages, read a few messages, and leave. For the most part, people stay connected during their entire workday. So for instance, the average user is actually intensively using Slack, right? So actively in focus, reading channels, writing messages, and so on for 2 hours a week for every workday. And they're connected on an average of 10 hours for the average workday. There's also this impression that everything, that Slack is kind of a Silicon Valley thing or something, that it's all startup people using it. 50% of our daily active users are from outside the US. So Europe, Asia, Africa. And we'll see how that trend goes over time. And a little bit about sort of our style of solving problems and the kinds of things to expect from this talk. So a lot of times people, when they talk about their consumer-oriented web stack, it's a little bit of buzzword bingo, right? They'll say we're using this, we're using that, we're using that, we're using that. We plumb together these two things that way. This is going to be a little bit of a different kind of talk from that perspective. If I were to pick a single adjective for the house style at Slack, it would be conservative. So the vast majority of what Slack is doing and what's challenging about what it's doing are storage and memory and compute and networking, handling failure. The hard part of these things are essentially hard the same way they were 10 years ago. And the things that have come along in the intervening 10 years, while sometimes better, are also 10 years younger and full of 10 years of bugs that we're not that interested in being the people to find out about. On the other side of this spectrum, we're willing to write some code. So for instance, when we get to talking about messages, A lot of times people expect Slack's message bus to be described as, we set up Kafka in such and such a way, and we tuned it like this to get low latency, and so on and so forth. And to be clear, there are places that can be successful with that style of solving problems. However, our experience so far is that the effort and operational know-how and monitoring and alerting and so on that goes into getting an off-the-shelf piece of software to do exactly what you want it to do sometimes is better spent telling the computer what you want it to do in the programming language of your choice. So our message bus, to go back to that example again, is a bunch of Java we wrote. And while that means that we invest software effort in building and maintaining a lot of software, it means that it actually does what we want it to do and that we have in-house experts that understand essentially all of it. And along these lines, we also have a taste for minimalism. There are relatively few core pieces of infrastructure that come from outside of Slack that we depend upon. So for instance, if you're proposing that we introduce some new dependency in Cassandra, we might have a long conversation of the form, well, why can't you do what you're trying to do with Redis or MySQL or some other system that we've already got thousands and thousands of server years of experience operating successfully? So I had to go to Comic Sans for this one because this is sort of a abusively crude picture of what's going on at Slack. But it's not entirely deceptive. So out here on the edge, down at the bottom of the screen, we've got our clients. Right? So they're happy, hopefully, Slack customers. And they've got some plurality of devices running Slack clients. Right? So maybe there's an iPhone down at the lower left running our iOS client. Maybe there's a laptop running our native macOS client or our native Windows client. And you can see that there's kind of two big gateways into the back end of Slack that these things end up cooperating with. One of them is the web app stack. And web app is a big RESTful application that I'll be talking about in more detail in a second. And the other one's the real-time part of our serving infrastructure, which I'm representing with a message server here. A quick word about, I'm going to be repeating this point over and over again a couple times. There's this fun fact about Slack that media stories really enjoy hammering home, which is that it started out as a game company, right, as a pivot from a massively multiplayer online game. And usually people just mention this as like some funny thing, right? It's like, oh, they were a game company, haha, isn't it weird how like cookies crumble sometimes? That's true. But it actually does kind of come back in certain ways and comes back to be meaningful in certain ways. And in a certain way, if you kind of squint and tilt your head, the actual architecture of Slack resembles the architecture of a massively multiplayer online game, right? So you kind of have your world that you operate in, which is your team. And in order to kind of make that world seem both persistent and sort of interactively mutable with other things in the world, you end up making a pretty thick cache of what's going on in that world. And then you've got some way of getting hopefully low latency updates for the changes in that world. So that kind of mental paradigm of, oh, it's kind of like an online game actually explains a lot of things about Slack. Like it's like why we have loading screens, for instance. That's the same reason that video games tend to have loading screens. So we're going to illustrate all these moving parts here. We're going to exercise all the bits on screen here by working through a worked example of a user logging into Slack and listening to messages and writing some messages. So there's this element of this that's just the internet, right? So when you go to mydomainname.slack.com, DNS does its magic, a bunch of Cisco routers are in the way, ELB, et cetera, and you end up somewhere in Slack's web app code, somewhere on a www machine that Slack operates. You'll hear me go back and forth between www and web app and the contraction web app because the GitHub repo is named web app. And the first thing that they do is this method that we call RTM start. So they're going to use our API. RTM in the context of Slack, by the way, stands for real-time messaging. So this recurs in the API a lot. Kind of trips off my tongue a lot. We say RTM start so much that I'll be saying RTM start a lot as well. And so real-time messaging start. This is saying, I'd like to start a session. You present some token, some auth magic happens, and so on. And a word about what's actually happening on the inside there. What's running there at that web endpoint is a PHP monolith. Right? Is a bunch of app logic, a little less than 1 million lines of code at this, as I sit here talking to you, that knows where all the business objects that describe your team actually reside. Right? They're out in some database somewhere. And if you kind of look at the DNA of this thing, you can recognize it as a very competently executed LAMP stack that has had to scale out. So for instance, it's memcache wrapped around MySQL. MySQL really is doing queries. For instance, it's not all just point queries. The actual engine we happen to be using for PHP is the hip-hop virtual machine, which is Facebook's JIT for PHP. It gets things a little bit faster, but it also gets us the option of using a gradual typing system for PHP called Hacklang. But from 100,000 feet, yes, it's really, really PHP. And usually when I delve into this, a sort of whole complicated and interesting conversation ensues, and I desperately wish we had time to go into this whole interesting, complicated conversation. And that conversation usually starts with, I like Slack, but I hate PHP with a raw passion that burns inside, and I don't know how to reconcile these two facts. They're confusing to me. And I wrote a blog post for our engineering blog recently that basically makes the weird claim that those are both true, right? That it is simultaneously true that PHP is essentially a bad programming language for almost every reasonable definition of bad, and that it's a very good choice for your application logic for something you're going to serve on the web. If you're really curious about this, I suggest you dive in there. But in the interest of talking more about how Slack works, I'm just going to leave that thread dangling for now and ask that you take me at my word on it. So now here's where things start getting a little strange, and there start to be a few forward references. So your team, all the business objects that represent your team, really are relational data inside of Slack. There are a bunch of tables that contain things like messages and users and channels. And they're designed in sort of a relatively normalized form. And it is also the fact that we're sharding by team, it turns out. Right? So team IDs get you to a database where your team lives. Probably lives with some other teams, unless you're a really, really active or really huge team, or both. That, when I say shard by team, people tend to assume that what that means is you take the team ID and you hash it, and you project that hash onto some address space, right? That you take that hash and you mod it, or you Kidama it, or whatever, onto some set of shards. That's not what's going on, right? The actual layer of indirection that goes from a team to the shard that it lives on is arbitrary. And it's arbitrary for basically administrative reasons. It's arbitrary so that if a shard gets hot, we can split it manually, or automatically in some cases. We're still sort of in the transition from manual to automatic splits. So that metadata of which shard a given team lives on another MySQL database that we call the mains, because they're a pair. But it's one logical database. And that thing knows which domain names map to which teams, and which teams map to which shards, and not a whole heck of a lot else. The process of sort of getting metadata off of the mains has been a recurring theme in our infrastructure over the last year for reasons that will become really clear. And with that information in hand, we go off and start actually constructing the payload for the response to RTM start. So remember, I'm claiming that Slack's a little bit like a massively multiplayer online game. RTM start is kind of the keyframe that bootstraps the simulation of it, right? It's the thing that tells you, here's the state of the world. Here's all the users. Here's all their profile pictures. Because for all you know, while that client was disconnected, everything changed. Right? For all you know, the last time I've connected to this team, it was only 2 people, and now it's 2,000 people, and they've all changed their profile pictures for the election and whatever else, right? So RTM start gives you back this big blob of data that's essentially, here's where we're at. And to do that, we do lots and lots of SQL queries. The most egregious offenders on this take something like thousands of SQL queries, so thousands of trips back and forth to this shard. And yes, fixing that is something that we're constantly working on. So a couple words about, I've kind of been whistling past the fact that there are these little pairs being illustrated here. I'm going to keep whistling past it for a second longer here, just bear with me. Those pairs are across 2 different data centers. Right? So barring sort of world historical scale crises, hopefully these things will be available for reads and writes given a single data center failure. And reads and writes, you say, Keith. Reads and writes, that's interesting. Yeah, hold that thought for a second. So MySQL is an unfashionable choice, a little bit like PHP. Not quite as bad a reputation as PHP. MySQL definitely does what it says on the outside of the box and is very carefully engineered. But still not what you're used to hearing when people talk about their scale-out storage engines. And probably the most important reason that we're using MySQL is just the collective history in the universe of the thousands of server years of operating MySQL without it losing data. We also actually like the data modeling discipline that relational imposes on us. We don't wish MySQL were a document store. We don't use it as if it were a document store, the way a lot of people scaling out MySQL do. And also, there's just a lot of in-house experience operating it and writing code for it and writing queries against it and diagnosing performance problems and figuring out when it makes sense to add a secondary index and so on. But don't think of this as some big arrow in the quiver of the NoSQL debates, because actually we don't. We throw away a lot of the strong properties of MySQL in the way that we're using it. Specifically, we use it in an active-active way. We do master-master replication. So you actually can write to either one of those heads. So each one of those heads is replaying a statement-based log and producing a statement-based log from its partner. And if you go out and hold a stethoscope up to one of these logical, it's a single database logically, but they're separate machines, they really will be sustaining write traffic on either side of this, and there really will be some lag in the replication as it crosses from one machine to another. So we've taken MySQL and made an eventually consistent store out of it. And we do this because basically we want to be write available in the case of failures, and we want master promotion to be automatic in the case of failures. Now, you might be wondering, what about conflicts? What if we actually wrote the same row on either side of these things, or we did something else inconsistent, like we tried to insert the same value? Conflicts do happen. So basically, when application authors at Slack are writing queries, especially update queries to this system, they need to bear in mind the possibility of this. And it's sort of something that comes up in code reviews a lot, is like, is this actually safe in the event of serious master-master lag or replication lag? If this write happened on both sides, would it be safe? And the majority of our conflicts that do happen, we're able to resolve automatically, basically with application knowledge. Right? We know what it's trying to do, and so we're able to resolve it. But there are human beings who work at Slack who have to resolve conflicts at a non-zero rate. And this is one of those things that, when I talked about sort of things that just aren't pretty but are true, that's a thing that's not pretty but is true. It's a thing that is not going to scale forever that we're currently doing. A bit of a kind of application level programming trick for making these things a little safer is a lot of these are kind of racy updates of the same structure, right? So you can imagine that I've got my laptop out and I've got my phone out and I'm trying to sort of change my profile picture in both of them to try and catch Slack in the act and get ABA to happen or something. For the most part, writes like that you're going to read what you wrote even though we're doing this master-master business, because there's a best effort to kind of read what you wrote semantics using the team ID. So the lower order bit of your team ID is your preferred head. Right? So even teams want to write on the left head, and odd teams want to write on the right head, as it were. And of course, they'll fail over to actually doing the writes on either side, so you still have to think about all these conflicts and stuff. But in practice, it's actually pretty hard if things are humming along in a healthy way to try to write the same row twice. OK, so we do all of these eventually consistent queries that let us construct the RTM start payload. And we return it to you, and it's got a lot of information in it. It's got the identity of every channel in the team. It's got the identity of every user in the team. It's got the membership of all the channels. It's got where the read cursor has moved ahead in all those channels since you last examined them, and blah, 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 blah. But the two pieces that we probably care about for our purposes are, it says, OK, you did start a session. I'm counting you as an active user for right now. And here's your WebSocket URL. Right, so there's a little WebSocket URL there. It's some host name at slackmessages.com, and then the actual application's named WebSocket, and then some funny hash of something or other. And we'll talk about what that funny hash is doing in a second. So the contract here is going to be, now that you've gotten your keyframe, right? Now that you've gotten your state of the world at the time you started your session, we're going to keep you up to date by trickling cache updates through that WebSocket connection. Right, so that WebSocket connection, if you're using it as a chat app, one of the really visible things that's flowing over that WebSocket connection is just messages going back and forth. Right? So that's where the write amplifier that actually takes a message you send, broadcasts it to everybody, that's where that thing lives. And you can see that operating. But going on behind the scenes is actually a lot of sort of quiet, oh gosh, so-and-so changed their profile picture. OK, cool. I'll show the right profile picture, and things along those lines. Also presence information. We'll talk about presence briefly, too. So diving into message server, I kind of gave a little preview of this briefly. Message server is an actual bunch of Java code we wrote. Its message in life is sort of twofold, right? So one is that it's a write amplifier. So things that happen on the team need to be shared to everybody that's actively using the team. And it also needs to be sort of communicated to the future. It needs to be communicated to all the people who aren't here in space, but will be here later in time. And so we need to store these messages somewhere. We were talking about all this discussion, foregoing discussion about sort of master-master replication and MySQL and shards and the left half and the right half and so on. That's all application logic. Message server doesn't know anything about it. It's in a different language. There's no unholy bridge between Java and PHP that we've tried to forge. It really side calls into a web server in a way that's not so different from the way that you'd side call over port 80 from the big bad internet, so that it can actually persist the message. And I'm making this sound like it's really simple, so you might be kind of like, is this literally just kind of 40 lines of code that opens that's a wrapper around a WebSocket library and then a for loop over the people that are connected? Well, no. So one of the things that I talked about there was that there's a contract here that you're going to get your updates over the WebSocket. You might have noticed there's actually a little race here, right? So RTM start gives you a WebSocket URL. Time elapses, things change, the world moves on a little bit, maybe some messages even get exchanged, and then you go over and start talking over the real-time connection to the message server, right? So that little hash of weirdness that came along with your payload, that's actually a little cursor in the event log that the message server keeps. So the message server keeps an in-memory buffer of recent events, and that thing's actually bounded in real time. I think it's 30 seconds. So in practice, you kind of have 30 seconds to go take the ticket that RTM start gave you and connect to the message server. And when you connect with it, it'll catch you up with whatever you've missed. There's also the fact that we're doing persistence across a network boundary, possibly a data center boundary. So it's actually possible that we're not able to persist a message for a while. And then what should we do? Well, you have the option of sort of the sort of clinical distributed systems answer is, whoa, like we're not in an OK state. We're not able to actually send your message right now. That is probably not the most helpful thing to do in this situation, though, right? Network weather does happen, and usually network weather is very brief. Seconds later, we will be able to persist it. So there is both an in-memory and on-disk queue that we try to recover that the message server operates. So it persists locally and replays the locally persisted log if it crashes and comes back up, or if there's something really terrible happens and it takes a long time for the message for the MySQL and web app to be able to talk to it. By the way, we really carefully monitor the depth of those queues. If those queues start building up, that's a really powerful sign that sort of something is badly wrong with the system, and it could be load anywhere from oh gosh, the peril of presenting on your own laptop here. Yeah, and it could be load anywhere from the web server, MySQL, or other systems that I haven't been able to talk about here yet. Also, the vast majority of messages in a large team are presence. What we mean by presence is the information that so-and-so opened or closed their laptop. So your intuition is probably most of what happens is you're sending chat back and forth because it's a chat application. Well, no, most of what you're sending is like the stuff that drives the little green dots next to people's names when they're online. That might seem wasteful, but this is actually a really, really critical feature. Like going back to the online game analogy for a second, those little presence dots are a lot of what makes it kind of feel like a virtual water cooler in a virtual place where sort of people are. You're kind of using your brain's location hardware to think about Slack channels sometimes. And the reason that presence messages proliferate, this is a little weird, but it's true, is that this is basically n squared in the number of people in the team. So if we actually tell every connected user about every other connected user's presence status, whereas like other ones are kind of narrowcast to channels and stuff, then it's just going to be the case that in the long run, you're going to be dominated by people opening and closing their laptops because they do that more often than they post a message in general that goes to every single user. There's another big box that we haven't talked about yet, which is the job queue. It's a work deferral mechanism. I know job queue is not a very inventive name, but that is what the code base calls it, and so I'll stick with it here. It'll be one of those things that'd be fun to make up a name for someday. We physically manifest this thing in Redis. So there's all kinds of stuff that you kind of don't want to do. I have a background as an operating system person, by the way, so I find this analogy just irresistible. In an actual web request, It's a little bit like the top half of an interrupt handler, right? You have real time. You're sitting there occupying a slot in like Apache's set of processes it can handle. You want to get what you're doing out of the way pretty quickly so that this server can go on to serve other users. But there are things that just inherently take a long time. A really extreme example is an import, right? If you're just importing years worth of data from some competing chat product or something, that's going to take hours no matter what we do. But we want to be able to kick that off using the web application, and we want it to have access to all the sort of application logic that I've been talking about before. But we don't want to just sit there squatting on an open socket over port 80 for hours at a time. So that happens through this job queue mechanism. If you're kind of in the top half trying to get your request finished in a timely manner, you can write a memo to the rest of the system to do work later. And we do the actual physical storage of that in a set of Redis clusters. I'm calling it the job queue, by the way. It's actually multiple queues. So we have different sort of levels of service class, some performance isolation by running them in different queues, different pools of workers. And the pools of workers are sitting there actively polling for work to do. They could use PubSub, but they don't yet. But actively polling for work to do and pulling stuff off of there. And by the way, this is one of those things that seems really the fun thing to take away from this slide, at least if you're me or if you ever end up working at Slack, is that link unfurling, which is like what we call it when we do the little cartouche around a link, right? So you're in some channel, you type https:// twitter.com/some username or whatever. After a second or two, hopefully, a little box shows up with that person's profile picture and sort of a blurb about what Twitter is and a little bit of their bio and whatever. That all happens in this job queue mechanism. You want that to be there because, right, sometimes external URLs fail, sometimes it takes a long time to curl something else, sometimes that site's just under load, and if you just retry again in 5 seconds, it'll be just fine. But I mention this because if I'm sort of just stuck on the subway and I'm trying to make sure that the site's still up and that I didn't break it with the code I just pushed or something like that, I just link unfurl something in a message to myself. And if I do that, I've just exercised the hell out of everything I've talked about so far, right? It means that the web's up. It means MySQL's up. It means the message server for my team is working. It means that Redis is operating in some sort of vaguely good way. It means that job workers are finding stuff from Redis in a timely way and actually doing the work that's on them. It means that the messages that go down through the message server that tell you that job is completed and tell you what to show now are actually functioning, and so on. Whew. OK, so we've kind of worked our way through our crude little picture here. We've got the mains, we've got the shards, we've talked about message server, we've talked about web app, how they're kind of the two big gateways for sort of the bulk, session initiation and termination, and then the actual kind of fine-grained, low latency session information. So there's a whole lot of stuff that I'm omitting here. So we don't use raw MySQL all the time. Memcache is there for a lot of performance critical queries. It's basically providing a materialized view of some queries that are important that keep recurring. This is currently totally manual, right? This is currently totally done by people noticing that, oh gosh, we spend a lot of time on this API endpoint. Why is that? Oh, it turns out it's this query. Is it easy to cache? Is it safe to cache? Yes, it is. And so they build it that way, the old-fashioned way, by hand. So there's no kind of magic framework that just automatically caches queries for you yet. I didn't talk about a service that we call CDS for the Computed Data Service. One of the S in Slack's backronym, right? So after Slack was founded, our founder, Stuart Butterfield, made up the acronym Searchable Linked Archive of Company Knowledge. But honestly, Slack was just a cool name, and that was sort of a plausible backronym for it. But I haven't talked about search at all yet. We do search, and it involves search quality, and that involves the sort of usual pipeline of search quality tools. And ML models and weights for linear models and things like that are currently provided by the CDS thing over a Thrift interface. We're using it for more and more things. It's the bridge between sort of stuff that we have to construct in our data warehouse in a batch way and real-time services. I didn't talk too much about rate limiting. There are lots of little pieces of this picture that I drew where if you poke them hard enough, really terrible things will happen. So a lot of those things are guarded by some version of a finger in the wind for what's a reasonable rate to use them at. And if we start exceeding that, we shed load and start alerting people. And by the way, the quick version of the nickel sketch of the Solar infrastructure is that we use Solar. It's powering search. Those search indices are updated in real time by job key jobs, because Solr itself sometimes is sticky and sometimes gets under load. And it's team partitioned, which is a complicated choice, but it sort of fits in the framework of lots of the other team partitioning choices we'll be talking about. So feel free to press me on this if you're curious about more later. So there are a bunch of cool things that fall out of this, the way that we've built Slack so far. One of the unifying themes that's a little unusual if you're coming from sort of a scale-out, consumer-oriented backend is that there's been team partitioning as a pretty pervasive decision. And as long as teams are sort of the dimension you're scaling along, right, as long as that's kind of how you're growing, this works really well. This lets you scale teams really, really easily. So if you ever go to slack.com and you sign up for a team, we're essentially provisioning an instance of this little box and arrow diagram I keep showing, right? We find you some shard to fit your team on. We slap it there. We find some message server that seems to have some spare capacity. We just tell you that's the message server that you're going to be using. We write a row out to the mains that says, hey, this team exists. Here's its domain name. Here's its name, and a few other sort of pieces of metadata, pointers to which shard and message server shard and so on it uses, and we're golden. And Slack, unlike a lot of sort of recent hot mass adoption consumer products, we actually charge our customers, right? People actually pay us money. And so this is actually a fairly nice layer of indirection to have from that point of view, right? If you have an angry customer who probably is angry because they're such great users of your product, right? They're probably angry because they use you a lot or they have a lot of users, who's having a bad time of things, being able to just say, okay, we'll put you on some nice fire-breathing, platinum-coated hardware is a nice economically viable sort of decision to make. Okay. So let me critique this. Not all is roses for us right now. We have a number of challenges like everybody else. And a lot of these challenges do arise from sort of some decisions that we've made in this architecture. So I'm going to walk through a few scenarios where the system that I've just outlined, which is, and this isn't like some weird punchline, by the way, like that really is how Slack works. So I'll walk you through a few scenarios that are difficult to deal with this kind of infrastructure. The mains. You might have wondered why I mentioned them. It seemed like sort of the kind of detail you might want to skip. They're a database. They're a pair of databases, but they're still a database. And terrible things can happen to them. And they turn out to be a single point of failure. I've been talking about RTM start a lot and emphasizing how it's this really big, bulky thing that kind of tells you everything you need to know about your team. That turns out to be really messy for large teams. If you are 1,000 people who share an office together, and the people doing sewer work on the street outside your office today happen to cut through your fiber line, and people get things working again at 3 p.m., and all 1,000 of you try to reconnect at the same millisecond, that also turns out to be really difficult for this infrastructure to handle. And just sort of diving into this some more, you might think, well, the mains, sure, like it seems like a single point of failure logically, but they're two physical machines. What's the big deal? It's true that if one of the mains fails, its partner is going to take over. If both of them fail, well, we've wrapped a lot of memcache around these things. So a certain number of people are still going to be able to log in. But as soon as they're down, the set of people who are actually able to log into Slack is sort of dwindling quickly. So if you're not a hidden memcache for your team's row from the mains, Slack's essentially down for you. And this might sound really far-fetched because you've already sort of sustained one failure. You said they're in two different data centers. Like, why did the other one fail? Well, how many people have had the experience of trying to sort of protect a system by replicating it and have the load be contagious, right? So those kinds of scenarios where the reason that one of them failed was because it was under too much load. Well, now you have twice as much load on the other half, and that one's probably not long for this world. So this has happened. The worst sort of outage in terms of sort of affected users in Slack's history was almost a year ago on November 23rd and was of 2015. And was an instance of mains failures. So this is still something that keeps us up at night. I talked about RTM start sort of being big. Let me put a finer point on it. It's not just big, it's actually quadratic. So as you add a new user to your team, there is some probability that user is also going to add a channel, and that the users that are already there are going to join that channel. So it turns out channel membership is naturally quadratic in team size. Right? You sort of have a rectangle that's m channels high and n users high, and it's moving up and to the right, getting bigger quadratically every time you add people to your team. So if you're in a big team, we're sending you a quadratic chunk of data when you start a session. And this was sort of hard to notice initially just because the constant factors are pretty small. But as you start getting into the thousands and tens of thousands, this becomes really noticeable. And making this even worse is sort of that mass reconnect scenario. So imagine we do have thousands of people, each of them doing these order of n squared RTM start operations. There's kind of n cubed load on the system. And this decision that we made of focusing teams on shards means that that n cubed load isn't spread across a nice ocean of sort of cloud capacity. It's concentrated on that single pair of databases that constitute this particular shard's master-master pair. So we're just going to lay down and die. It's a bummer. It turns out it all ends here. The jig's up. If you guys have a job for me, I'm pretty smart. I'm good at programming computers sometimes. No, of course not. Of course not. We're not giving up there. Don't worry. Never. So with the mains, we're very lucky. So currently they're MySQL like everything else. They're essentially another instance of that sort of MySQL master-master pair design pattern. We do very simple queries against the mains and very simple updates against the mains. The updates are almost always adding a row or modifying an existing row. The queries are always point queries. So you don't need some incredibly special properties or some incredibly strong properties from, pick your favorite scale-out storage engine to replace the mains with. Why hasn't it happened already? Well, it hasn't happened already in part because we've gotten really good at protecting the mains through a combination of memcache and the kind of rate limiting I was describing earlier, but also because it's just a really hard thing to change. When we finally kind of work up the nerve to do this, it's going to be a very difficult and delicate operation to do it in a way that doesn't actually take all of Slack down. And we have ideas about how to do that, of course. We'll tee the writes and double read and do run the whole playbook for how you deploy stateful services that are scary. It just hasn't bubbled to the top of our list of priorities yet. A little more to say about RTM Start for large teams. So first of all, partly incremental work has just been astonishingly successful at this. So even though there's this bummer kind of big O story about it being quadratic, the actual distribution of latencies here is not unacceptable. P95 is around 221 milliseconds, right? So barely perceptible. P95 is well over half a second, but we're not with that n squared there. You might think that there are people sitting there growing old while they try to connect to Slack, and that doesn't seem to be happening mostly. And we're in the process right now of actually changing the story around the client architecture I've been telling you, right? So instead of having a complete view of the team, we're in the process of migrating all of our clients, and there's several of them, and they're in different code bases, to be able to understand a partial view and give you separate APIs that let you do partial queries of channel membership. And I'm using the channel membership example because it's real easy to understand, but that kind of quadraticity as you add users keeps popping up in lots of natural places. My favorite example of this is just emojis. Right, so Slack lets you add custom emojis. You can name an emoji, give it a little 32 by 32 thing. It might even be animated. And it's relatively natural as teams grow to go through this life cycle where they kind of have emoji bloat, and then some administrator decides to clamp down on it, or some sort of no fun person says, hey, this is work. Why do we have all these animated emojis of parrots? But until you reach that point, emojis are also one of these kind of quadratic things. And I spent a bunch of time looking at emoji performance when I first started back in January. And then in Mass Reconnects, I get to introduce a new service that we're calling Flannel. And I keep trying to come up with some clever name for what flannel means, some sort of pun on channel, or maybe Spanish, Mexican desserts, like the flan or something. We've got nothing. It's just named Flannel. I'm sorry. And what is it? Well, Flannel is an application-aware edge cache. Right? So it's an edge cache that, let's unpack that. It's a cache, so it has some of the information that we need to start and run these real-time operations. It knows about Slack, right? It's specific to Slack. It's not some generic thing. It's not operating on sort of arbitrary RESTful things or something. It knows that the thing that it's trying to do is accelerate Slack connections and sessions. And we don't necessarily run it that close to the data center, right? We're running it on hopefully nice gear with good network connectivity, but we'd like to be able to run this in a closet that we're renting from somewhere far around the world, hopefully. So our sort of before picture of the real-time part of the stack looked like this. And we're in the process of changing it so that it looks a little more like this. So a couple of observations about this. First of all, this looks like a really silly change to be making, right? I've added a hop and a layer of indirection. Presumably we have to pay money for those computers. Why are we happy about that? Well, that layer of indirection is doing a couple of things for us. First of all, it's keeping load off of the actual web backend. So if a lot of the functions that sort of RTM start used to take up are now happening when you connect to Flannel, we're actually able to serve that in a way that scales out a little more straightforwardly. You notice there's two of them, right? So we can actually scale edge capacity for Flannel separately from scaling the backend. Right? So we don't actually have to make some big painful migration to scale out all the shards, for instance, right? We don't have to find, we don't have to migrate to MongoDB or something like that, which would actually be a challenge, by the way. I didn't kind of get too deep into this, but we really do use SQL. The database engine does work for us. We're actually relying on the query planner to be smart. There are joins and stuff, right? We're not using it like a document store. So being able to cache the application level results of that, sort of closer to the user logically, provides a nicer place to scale out a little bit. And this is not all pie in the sky. I did an engineering blog post like back in spring about how we were planning to do this. At that time, we were calling Flannel Slackd. Its creator since then has actually gotten started on it, wanted to call it Flannel, so we're calling it Flannel. And this thing actually exists. So Slack's internal team, the team that we actually all live off of, all 650 Slack employees are using it. There are a few other teams that we're using it for because it sort of addresses really critical problems that they're experiencing. And with any luck, it's coming to you real soon now. There's a version of these slides that kind of was premature and jinxed it. But this is not sort of a, sometime in 2017 when we get to it. This is real code that we're in the process of sort of figuring out how we're going to deploy. OK, then. So let's take a little breath here, think about some of the things we learned. It pains me to highlight this, but of course there's a lot going on that I wasn't able to go into here. I'd be incompetent to answer a lot of interesting questions about the client technology, but we do have clients and they're complicated software too. If you look at sort of the distributed system that is Slack, in terms of the number of cores, the amount of storage used, the amount of memory, the flops, the bandwidth, the vast majority of it is in phones and laptops, not in computers that we operate or are able to administer. We do voice calls. There's a whole bunch of infrastructure on the back end to make voice calls work well, and a bunch of technology in the clients also to make voice calls work well. And there were a bunch of interesting trade-offs there. I haven't told you how we back any of this stuff up, how any of this information ends up in a data warehouse. I very briefly thumbnail sketched search. I haven't talked about how we deploy code. We do that about 40 times a day to the web application, and the infrastructure that supports that and lets us do that with confidence, and lets us convince ourselves that we're not breaking tests and that the core workflows inside of Slack still work with all those changes. To enable that kind of high velocity is itself very interesting. Monitoring alerting is also a critical part of running Slack. There's a really rich kind of smorgasbord of stuff that I could be talking about, but it seemed like the interest gauge for people who want to talk to me about Slack are usually more interested in sort of this basic kind of, what is the 100,000-foot picture view of it. But there are many, many careers worth of stuff to learn and do and problems to solve here. So we did the 100,000-foot view as promised. We talked a little bit about our big PHP monolith and why you shouldn't hold that against us if you are currently inclined to. We talked about the unusual way we use MySQL. We've kind of used MySQL to make an eventually consistent store that's highly available for writes under failure. Talked about how our real-time stack works and how we defer work. We talked about a bunch of challenges we face, a lot of them around sort of how slow reconnects are and RTM start and the fact that failures and reconnections are often correlated in time and we need to handle that. And we got to explain a little bit about Flannel, which is a big part of our solution to that story. So this is work in progress. There's a lot to do. There's contact info for me on the slide. Obviously, I would be remiss if I didn't mention that we're hiring. And with that, I thank you for your time. I'd be happy to take questions.
OK. So if anyone has questions, please raise your hand, and then we'll hand a mic to you.
Hi. What happens when you get a third data center? How will the active-active and replication work in that case?
Yeah, so one of the interesting things about this master-master thing is there's actually no obvious way to go from n equals 2 to n equals 3. And the answer is that is one of the bridges that we actually need to cross. So a current possible answer to this is that we just sort of go a more conventional route and do master-slave. So maybe there is a write head data center, and writes just have to make their way back to the write capital of the world. Maybe we can have that write be per shard, and we try to make it so that you're geographically close to the write head for your particular shard. I could speculate. We haven't really built it yet. But that's a solid observation that there's not a totally obvious way to sort of make the master-master stuff work. If you're thinking, why can't you just kind of make a ring of 3 and say, here's A, B, and C, A replays to B, B replays to C, C replays to A, it turns out that doesn't work. And ask your local MySQL expert if you're curious about why. Basically, the bin logs don't get replayed, so they don't echo forever, so the one from A doesn't make it to C.
Thanks for this great presentation.
So
I have a question about how do you handle hotspot for your shards?
Yeah, great. So the question is, how do you handle hotspots for your shards? Currently, we handle it by alerting and having people scramble to split a shard that's hot. And if that doesn't work, we handle it by paying for even fancier hardware to run the shard on, and by hiring hopefully smart people like yourself to come work for us and come up with a solution that's going to work better and be more automated and hopefully not break everything about the application in the process. Does that answer your question? All right. Honesty, yes.
It's working? So you didn't think about security. So lots of teams share lots of documents through Slack and maybe some confidential information like password or stuff like that. So how do you make sure that this information lies in your servers and only our team access these servers? Not only even your team can have access to this data, even if they are authorized to see MySQL database or the encrypted message if you encrypt them. This is my first question. My second question, I know that you want Slack to replace the normal email flows between the team. So I had this case that one of our team members just left the team, and all the information that he wrote to us, including descriptions, conversations, documents that he shared with the team, is gone. Okay. How would that replace the email if it's gone?
Okay, those are a couple interesting questions. The first one, and I should say, by the way, that I'm not an actual InfoSec professional, so my understanding of this stuff is especially secondhand and amateurish. However, one of the advantages of sort of the team sharding approach that we didn't go into too deeply here is that it does make attempts at intrusion a little more legible. Right, so it does make sort of attempts to exfiltrate a team's data or something a little easier to see. One of the things that is a little opaque from the outside that we're more careful about than than I think some of our competitors is that people don't have access to the production environment. Right, I don't have access to the production environment. I don't have I can't run queries against the production MySQL shard. There is glass I can break in case of emergency that enables me to do that, for instance. But that's obviously heavily audited, and the people in our security team have tooling that they refuse to tell me about that they claim is keeping that stuff on lockdown. And that's kind of one of the things that's different about a paid product that we're asking people to trust their company's information with. In the case of the second one, where my understanding is basically you're saying that somebody left the team and they kind of took all their information with them when they left the team. That is not how I understand the product to be supposed to work. Right? So when users disappear, they still kind of have an identity in the product. And things like your DM threads with them should still be there. Files they created should still be there to the best of my understanding and shared in the same places. But if you have a repro of this and if you're able to share any details at all, hit me up and I'll try and dig into what actually happened there.
We have time for one more question.
Great presentation, thank you. Are Slack engineers happy with PHP?
So it depends on the engineer. The question, if you didn't hear it, is are Slack engineers happy with PHP? So it depends on the engineer, right? And so I'm coming from 7 years at Facebook, so I of course feel like this is the old sword, right? I know exactly what the scary parts are and exactly how to use it so it doesn't break. When you're coming to it new, there's a bunch of things that are actually surprising. I think by and large, once they've adapted to our code base and our conventions for using it well, I think most probably wouldn't say that they love PHP, the programming language, but they sure like deploying 40 times a day. And it turns out that's those two are sort of fundamentally in tension in an interesting way. So I'll sell my blog post again if you don't mind, if you look for taking PHP seriously.
All right. Thank you, everyone, for coming, and another round of applause for our guest.